First, we're going to go over, first reminders. So you have some homework due tonight, 1 point for the material I'm going to go over today. Okay, so let me go find my math lab, and we're going to go to 3.2. And I pick question number 7. So can somebody let me know? You can see the My Math Lab problem. Somebody let me know that. Okay, thank you. Just want to make sure. All right, so I picked this one for a couple reasons. You could do a whole truth table for this one on a piece of paper, but I did it with my class yesterday, and we actually were able to do it line by line. So let's see if we can do that together. So here's the compound statement up here. What you want to do is the part in parentheses first, and so they're having you actually fill in each line of the truth table, making the whole decision at one time. So let's go through it systematically. So first we're going to go in the parentheses, and we want to take P, and P is true, or not R. R was true, so not R would be false. So true or false gives me what? True or false? You can tell me. True or false would give me true, right? And then I want to take that or Q, which is also true. So true or true gives me true. Okay, let's go to the next one. P is true. R is false. Negation of R is true. So true and true is true or true rather is going to give me true. And then I want to go Q. Q is true. So true or true is going to give me true. Okay, line 3. P is true again. R is true. Now we're going to negate it, so we're going to get false. So true or false gives me true. And then I'm going to compare that with a false. True or false gives me true. Okay, now we're on line 4. P is still true. And we're comparing that to not R. R was false, so not R is going to be true. So true or true gives me true, or false gives me a true. So we have 4 trues in the beginning. Let's go to the next line. Now my P's are going to be falses. Remember the last 4 cases in the 3 simple statement truth table have falses. So we're always going to have a false now. False or, now R is true, now it becomes false. So false or false is going to give me a false in parentheses, or true, false or true gives me true. Next one, I've got a false or, let's see, R is false, now it's true. So I've got a false or a true gives me a true, or true gives me another true. We got a lot of trues here, don't we? Next time we've got false or, now this time R is true, so the negation is false. So I've got false or false gives me false or false. Now I've got false. And then finally I've got false or, let's see, R is false, so not R is true. So that gives me a true, or false gives me a true. Let's see if we got it. Hold our breath. We did. So this is doing it line by line. Now I still recommend for students, I just wanted to show you how you do that line by line. I still recommend, let me go back to it for a minute. I would still write the whole truth table on a piece of paper, but this is how you could do it line by line. So line by line, you're putting in the truth values, kind of like those problems where they give you a compound statement and they give you the truth values and say, is this compound statement true or false? One line of a truth table. So that's another way to fill in a truth table. Number 12 is another one I picked. Okay, so this one you're going to translate from the words to the symbolic form. Here's your P and Q. You did the laundry, which would be a P, or you did not leave the garage a mess. And you've got a drop down here. So we know we want a P first, and then we have an or, so we've got a disjunction. So it's got to be one of the last 2. You did not leave the garage a mess, so it's got to be the last one. Now on this one, you don't get to check till you're finished. So it's going to be you're going to have to hold your breath and see. Now we're going to go line by line on this one. So this has got true or, Q here is true, the negation is false. True or false gives me
True.
True. Next line, true or Q is false, negation is true, so that's going to give me another true. Now I've got a false or, now Q here is true, so the negation of Q is going to be false, so I've got a false or a false, so this is going to give me false. And then I've got false or Q is false and the negation of Q is true, so this one's also true because this was a disjunction. So you only had to have at least one true. Let's see if we got it. We did. Okay, and now there's another question with this one. This is why I wanted to go over this one with you. What set of conditions make the compound statement true? Now we notice it's true in 3 out of 4 cases. So when is it true? It's true, let's see. Let's take a look. It's true whenever P is false and Q is true. Whenever P is false and Q is true. Well, that's not correct because it's not true here. The statement is true whenever P and Q are both false and is false otherwise. That's not right. It's true whenever P and Q are both true, false otherwise. Nope. It is true when P is true or Q is false. P is true or Q is false. That looks pretty good. P is true or Q is false. That looks pretty good. D. It's true when P is true or Q is true. P is true or Q is false and false otherwise. That's not correct. It looks like it's D. Let's take a look. Yep. So you had to really think on that part of the question. And then I wanted to do this one too. That was 12, 13. So this is, and I'm going to pull this over a little bit so I can bring up the whiteboard. This is one of the ones where they give you a compound statement and then they give you the truth values. You're doing one row of the truth table. So what do we have? We have, okay, so we've got, I'm going to go back to blue over here. We have P and not Q and R. Okay, so in part A, they tell me that P is false. So I've got a false. Q is false, so not Q is going to be true. And R is true. Okay, so on the left side here in parentheses, I've got false and true, so that's going to give me false. False and true gives me false. Okay, so the first part must be false. And they're going to give you another set of, oh no, what did I do wrong? Uh-oh, what did I mess up? This was false. Q was false.
You chose false instead of true, or true instead of false.
Oh, thank you. Thank you. That helps, doesn't it? Okay, let's try the second one. Thanks, Rebecca. So we got it right over here, but we just didn't pick the right answer and went over there. That's a bad thing to do, is it? Okay, same compound statement. If P is true, so now we've got true. Q is false, so not Q is true. Whoops. And R is false. So here we've got true. Whoops. Oh, shoot. Wait a second. Let me erase that. Oh. Okay. False. So this is going to be a false, another false, right? Let's make sure we pick false and don't pick the wrong one. There we go. Wake up. There we go. So I'm not sure why that was causing problems, but it seemed like a number of students took more than one attempt to get that one right. But that's all you do on those. That's like, this is like one row of a truth table. And then I picked number 19, which was real similar to one we did in class, actually. So number 19 was one of the ones where you're looking at a graph. Here we go. Okay, this is the one with the hours of sleep. So it says, use the graph which shows the number of hours Americans sleep to determine the truth value of each simple statement. Let me pull this over a little bit. Then determine the truth value of the compound statement. So the first simple statement is 9% of Americans get 8 hours of sleep each night. And it's a little tiny here to see it, but let's see if I can make this a little bigger. There we go. 9% of Americans get 5 hours of sleep a night. 5 hours of sleep, 9 hours, that's true. So we're going to put a true on that one. And then the second statement is 4% gets 7 hours. That's false because it's actually wait a minute, 7%. Wait, 4% gets 7 hours. That's false. Yeah, that's false. 7 hours is right here, 30%. That one's false. And then, so now what is the truth value of this compound statement? It is false that, now remember that's a negation. Let me bring over the whiteboard again. If I can find it on my tool palette here. Okay, let's get a new page. Oops. Come on. There we go. So it is false that, let's look at the statement. 9% of Americans, so that's going to be, let's let that be my P. That was my first statement. P and, oops, Q. All right, so what were my truth values that I had here? I had a true and then a false. So negation, true, whoops, erase. Keep that negation outside till the very end. So true and false gives me false. Take the negation of it and I get true. So the compound statement, if I go all the way down here, should be true. Yep. Okay, this one was actually a little bit easier. This was like the one we did in class. This is exactly the one we did in class last week. The one I just did was a little bit easier. All right, while I'm out here, are there any other questions that people want to go over from any of the homework? Oh, that's another one. Okay, any problems you want to go over from 1.1, 3.1, or 3.2 while I'm out here? Now's your chance. Looks like you were doing pretty well.
7.
On which section?
3.2.
Number 7?
Yes.
Okay. Okay, so this is like the one we just did.
My 7 is with the little squiggly line with the Q.
Well, I'm not going to get the same problem you get because they're algorithmic, because every time you get a new problem, it's going to come up with a different question. So I'm not going to get the same one you have.
Gotcha.
If you're having trouble on yours, send me up here on Ask My Instructor, and it'll send me the question that you're having trouble with.
All right. Thank you.
Okay. Yeah, because when I pull it up here, it's not going to be the same as you get every time. Because every time we do it, because look what's going to happen when I go away. It's going to say, oh, you already did this one. And then when I go back, it's going to go back and keep the other one that I had. Yeah, so it's going to keep the original one. Yeah. Sorry.
Thank you.
You're welcome. Okay. Anybody else while we're here? Nope. Okay. All right. Okay. So let's go. Okay, let me just stop sharing for a second. Yeah, it's probably easier for me to go over here because we're going to work problems. We've got things to work out today, so I'm going to go ahead and share this way. So let's go here. Oops. And share here. All right. Okay, so this was in the handout, and we're going to work some things on the paper, so that's why I'm over here. So remember, last week you did truth tables for the negation, for the conjunction, and the disjunction. So this time we're going to do the conditional and the biconditional. And the first one we're going to go over is the truth table for the conditional. And that's written as it's shown here. If P, then Q. And P is called the antecedent and Q is called the consequent. And let's consider a statement. I'm going to try to motivate for you when this compound statement is false. Let's consider this statement. If you get an A, let's say in this course, then I will buy you a car. So we're going to let P be, you get an A, and Q be, I buy you a car. And so we can write that compound statement as P arrow Q. Okay, so there's the 4 cases. Now, in the conditional truth table, the only time this compound statement is true is when the antecedent is true and the consequent is false. All the other cases are true. And students always say, why is that? So let's take a look what the cases mean with the P and the Q that I picked. So I said, if you get an A in the class, I'll buy you a car. Okay, so if you get the A, then I buy you the car. So that's case number one right here. That's got to be true. Now, what if you got the A in the class and I didn't buy you the car? I already told you I'd buy you the car. So that's the case that's false, because I already made the statement that if you get the A, I'll buy you the car. So when you have a truth value that has P true, Q false, that compound statement is false, because I already promised you if you get the A, I'll buy you the car. What did I tell you I'd do if you didn't get an A? I didn't tell you anything. So therefore, the consequent in either case here doesn't really matter, the truth value of it, because I didn't tell you anything about what was going to happen if you didn't get an A. So both of these cases are true, no matter what happens in the consequent. So if you don't get an A and I still buy you the car, that's pretty good. If you don't get an A and I don't buy you the car, that probably wouldn't surprise you. So those two cases are true. The only time this conditional statement is going to be false is when you have a true antecedent and a false consequent. So true to false makes a false compound statement. And I try to help this motivation, this explanation help a little bit, because students really never understand, well, why is that one false? It just doesn't seem logical. But if you think about this example, it might make a little bit more sense. Okay, so we looked at the summary up there. So there's a little statement about it. The conditional statement, if P then Q, is true in every case except when P is true and Q is false. So if remember, go back to our conjunction. Conjunction is true when both P and Q are true. Disjunction is true when at least one of the P or Qs are true. The conditional is true everywhere except when P is true and Q is false. All right. Now let's take a look at the biconditional. So this is the last connective that we're going to talk about. So the biconditional is actually, and in your book they've shown you the truth table for this, it actually means if P then Q and if Q then P. Basically that's where the truth values come from, is evaluating this compound statement here. And if you look at the truth table, here it is here. The biconditional is going to be true when both simple statements have the same truth value, when they're both true or they're both false. When they have opposite truth values, the biconditional statement is false. And again, if you want to see why that is, if you look in the e-text in this section, they have a truth table, or I have it in the section notes. They have a truth table for this compound statement here, which is actually what this is equivalent to. And it'll show you where the motivation comes from, where it actually comes from in a truth table. So the biconditional is true in every case where P and Q have the same truth value. That is, they're both true or they're both false. Okay, so conditional we learned today, true everywhere except when we have a true antecedent and a false consequent. And the biconditional is true when both simple statements have the same truth value. Now, there are some special kinds of truth tables or special kinds of compound statements. Self-contradiction is a compound statement that's always false. So when you do the truth table, the very last column, the decision column's got all falses in it. A tautology is a compound statement that's always true. So in your last column, your decision column, they're all going to be truths. And an implication is a special kind of tautology. It's a conditional statement that's a tautology. So implication is like a subset of tautologies. Every implication is a tautology, but every tautology is not an implication. All right, so let's try some problems from this section. So back to our truth tables. So we're going to do this one here. So we have a conditional statement, if P then not Q. So what kind of a statement is it? It's a conditional statement. And how many columns do I need to evaluate it? Besides the two on the left side, I need 3 more columns because I've got P, I've got the arrow for the connective, and then I've got the not Q. So I'm going to start in the P column. I'm going to put my P's in, true, true, false, false. Then I'm going to go to my not Q column, and I'm going to look at my Q column. I'm going to negate the truth values here and put them over here. So false, true, false, true. Okay. And then I'm going to look. Remember, the conditional is false when I have a true to a false, which I see in the first case here. True to false, so this one is false. True to true, true. The last two are falses as the antecedent, so I know right away they're going to be true. So the only time it's false is the first case where I had a true to a false. All right, any questions on that? That's a basic conditional truth table. All right, let's try a biconditional. Not P, if and only if, not Q. So what kind of statement is this one? This is a biconditional. And again, we need 3 columns here because we have 2 simple statements and the connective. So my first column is the not P. So I'm going to take the P truth values and negate them when I bring them over. And then I'm going to go to column 2, which is the not Q. So I'm going to go false, true, false, true. And then I'm going to compare columns 1 and 2 when my connective is the biconditional, which is going to make the compound statement true when I have same truth values. So false and false gives me true. Opposite truth values makes it false. Opposite truth values makes it false. Same truth values makes it true. Okay, so let's just go review for a second. So the conditional, go back up here, was only false when I had a true to a false. Everything else was true. Biconditional, true when my simple statements have the same truth value. So it was true in case 1 and in case 4. The middle 2 cases were false because the truth values were opposite. Okay, let's do let's do some more problems. I got you a big one this time. 3 simple statements. Lots of decisions in here. So we've got a biconditional, we've got a disjunction. Let's see, so what kind of a statement is this? What's my last column going to be? The last decision I'm going to make is right here. So this is a biconditional. And I need a lot of columns this time, don't I? I need 1, 2, 3, 4. I need 5 columns over here, which I already put out for you. Okay, so I start in the parentheses, and I'm going to start with the P column, and I'm going to take the P truth values and move them over. True, 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 false, false, false. Then I'm going to go to the not R column. And if you remember the pattern on R this time, it alternates true, false, true, false. If I'm going to negate it, it's going to alternate the other way. False, true, false, true, false, true, all the way down. Okay, so I'm comparing 1 and 2 with column 3 connective, which is OR. So what am I looking for there? It's going to be true when I have at least 1 true simple statement. So the first 4 are definitely all true because P is true there everywhere. Okay, case number 5, I've got a false and a false, so that's going to be false. In the next case, I've got a false and a true, so that's going to be true. False and a false is false. And then the last case is true. Now, if you remember the other day, I always like to cross out when I'm done. So I'm going to cross out. Just put a line through so I remember that I'm not using columns 1 and 2 anymore. I'm finished with those. Now I'm going to go over and put not Q into column 4. So my Q's go 2 by 2, true, true, false, false. When I negate them, it's going to go the opposite way. So it's going to go false, false, true, true, false, false, true, true. Now I'm comparing 3 and 4 with a biconditional. So what's my rule? I'm looking for the same truth value for that compound statement to be true. So case 1, I see a false and a true, so that's going to be false. Second case, I see false and a true, so that's going to be false. Third case, I've got a true and a true, so that's going to be true. Fourth case, true and a true is going to be a true. Fifth case, I've got a false and a false. That's also true, same truth value. Sixth case, I've got a false and a true, so that's false. Seventh case, false. And the eighth one is true. So again, remember, biconditional, same truth value. We had one false and false here. We had a couple true and trues. And so here, this is my last column, that's my decision column. All right, questions so far? Okay, now we're going to translate and then we're going to put it into a truth table. So write the statement in symbolic form and construct a truth table. Let P equal I eat too much, Q equal I will exercise, and the compound statement is I will exercise if and only if I don't eat too much. So how can I write that symbolically? Anybody want to try? It starts with I will exercise, which is
Q.
Q. If and only if is that double-sided arrow. I don't eat too much, so that's going to be negation of P, right? So I'm going to go ahead and put that into my table up here. And then bring over, let's label them. So this is going to be 1, 2, 3. So let's bring over my Q truth values, true, false, true, false. And then in column 2, I want to negate the P's. So I'm going to make that false, false, true, true. And now my connective is if and only if, so I'm looking for the same truth values. So let's see, the first case is false. Second case, I've got a false and a false, so that gives me a true. Third case, I've got a true and a true, that gives me a true. And the fourth case, false and a true, gives me a false. So second and third cases are true. All right. Okay, now, more practice with truth tables. Now we want to make a truth table to determine if the statement is a self-contradiction, a tautology, an implication, or none of these. Now, it's important to notice that this is a conditional statement, so it possibly could be an implication if we end up with all truths in the last column. All right, so where are we going to start? We're going to start over here. I'm going to bring my Q's over, start in the parentheses. So true, false, true, false. And then I'm going to go over here and bring my P's over. True, true, false, false. And my connective here is or. So what am I looking for in my simple statements for that to be true? I'm going to have at least one true simple statement, right? So case 1 is true. Case 2 is true. Case 3 is true. Only the last one's false. And again, I'm going to cross out this column and this column because we already used those. All right, so let's go to column number 4. We went the P's again. So true, true, false, false. And then my last column is the conditional connective. Now, the only time that's false, remember, is when we have a true to a false. And let's take a look. We only have 2 trues here, and they both go to true, so we know both of those cases are true. These are both falses, so we don't even have to look on the other side because we know they'll be true. So what do we have here? They're all true. So this is a tautology, but more specifically, it's an implication because it's a conditional statement. So there's all truths in the last column, which makes it a tautology, but because the last connective that we worked with was a conditional, it makes it an implication. So an implication is a special kind of tautology. So no matter what truth values we started with over here, this compound statement here is always going to be true, which is kind of interesting when you think about it. Always true. Questions? No? Okay. All right, so similar to what you did before, determine the truth value of the statement if, and I give you two sets of true and falses here. Okay, so let's take a look at each of these. So let's start. So we have lots of negations here. Let's see. So let's see. Negation Q. So Q is true, so the negation of Q must be false. And then it's a conditional. And let's see, R was false, so the negation of R must be true. And then P is true, or R is false. Looks like I'm going to run out of room here. I'm going to have to move it over a little bit. Let's see, let's make our decisions. Let's see. So I still got the negation outside. I've got to keep that. So false to true on a conditional gives me true. And then true or false over here gives me true. Still inside of these brackets, true if and only if true gives me true, right? Same truth value, but I still have a negation outside. Let me come over here. So this is going to become negation, true, and then the final answer is going to be
False.
a false. Yeah. Sorry, I ran out of room there. I didn't give myself enough space. Okay, let's try this one. Similar, just different truth values. So I've got negation, and let's see, negation of Q. So Q is true, so this time we've got a false. What do we have? A conditional. And then we have not R. R is false, so not R is true. And then we have P is false. And R is false. Okay, so false to true on a conditional gives me a true. False or false gives me false. Biconditional different truth values gives me false, but on the outside I have the negation, so my final answer here is going to be true. So this was opposite truth value. So again, this is like two rows of a truth table for the same compound statement. Okay, and then let's try one of these ones with math in it. Determine the truth value for each simple statement and then use the truth values to determine the truth value of the compound statement. 8 times 2 equals 20, if and only if 7 plus 6 equals 13. So I said, let's let P be 8 times 2 equals 20. Is that true or false? That is false, yep. And let Q be 7 plus 6 equals 13. Is that true or false?
True.
That was true, yep. Now you want to write it symbolically. So this is pretty straightforward. This is just P if and only if Q, right? And we have a false, let's put it down here. We have a false if and only if a true. So the compound statement here must be, whoops, false. Because my first statement was false, and first statement's false and my second statement was true. So for biconditional, again, in order for it to be true, they have to have the same truth value, and they don't this time. So this is a false compound statement. So, all right, questions? So that was conditional and biconditional. Oh, I have one more. Oh, I have one more. Another graph question. Okay, so the graph below shows the number of credits in various categories needed by Arturo to earn his Associates of Arts degree from Van Pelt University. Use the graph to determine the truth value of each simple statement and then determine the truth value of the compound statement. So here's the compound statement. If the number of elective credits needed is 21 or the number of communication credits needed is 15, comma, then the number of humanities credits needed is equal to the number of math credits needed. So there's 3 simple statements, which I put down here for you. The number of elective credits needed is 21. Is that true or false? That's true, right? That one's true. And the number of communication credits needed is 15.
False.
That's false because it's 9. And then it says the number of humanities credits is equal to the number of math credits.
True.
That's true. Yep, that one's true. Okay, so now we have to write the statement symbolically. So it's an if-then statement, I know that. And I know I need some parentheses here because, how do I know that? Because I've got a comma. When I was reading it, I said that. There's a comma right here. So it says, if the number of elective credits is 21, which is my P, or the number of communication credits is 15, that's my Q. So if, then, and there's my R. So that's what it looks like symbolically. And then if I drop my truth values in, what do I have? I have true or false to a true. So true or false gives me true. True to true gives me true. Yep. So you have at least one like that in the homework. That's why I like to give you an example like that. Okay, questions on that one? Trying to get you to apply kind of a real world stuff here. Oh, those are the answers. Okay, let's put this aside. We already did those. All right. Okay. All right, so that's section 3.3. So that was the conditional and the biconditional. And then we also talked about contradictions, tautologies, and implications. And then the last section we're going to go over is equivalent statements. So 2 statements are equivalent or logically equivalent if they have the same truth values in the answer decision column of the table. And we use one of these 2 symbols. I don't know if you can see these here. This is like an equal sign with 3 bars instead of 2, or this double-sided arrow here to say that they're logically or equivalent or logically equivalent. Now, we have De Morgan's laws. We had De Morgan's laws for sets. Well, we have De Morgan's laws for logic. And so they kind of look like De Morgan's laws from sets. So this says that the negation of the conjunction is logically equivalent to the disjunction of the negated simple statements. And the negation of the disjunction of the simple statements is logically equivalent to the conjunction of the negated simple statements. So it's very similar to the De Morgan's laws for sets. Now, there's a couple other equivalencies which are really nice to know about. You can change a conditional statement to a disjunction this way. So you're going to take, so here's the conditional, here's the disjunction. So the P becomes not P, the conditional becomes the disjunction, the Q stays the same. So P becomes negation, symbol goes from conditional to disjunction, the Q stays the same. Those 2 compound statements are logically equivalent. Here's a couple others that are. Here's a disjunction. This is just really turning around what we did up here, basically. It's going the other way. So we have, remember we went from P to not P. If you go this direction, we go P to not P. Disjunction becomes conditional, Q stays the same. So these are basically the same statement reversed. It's also nice to know this one, the negation of a conditional. Negation of, if P then Q, it's logically equivalent to P and not Q. So that's another nice one to know about. And sometimes in your homework, they'll actually give you these as tips to say when they're asking you to rewrite a question, they'll say, use this fact. Some other things that are nice to know are variations of the conditional statement. So the original conditional statement was written like this, if P then Q. We have 3 variations. The converse flips the simple statements around, if Q then P. The inverse negates each of the simple statements. If not P, then not Q. The contrapositive flips and negates. If not P, then not Q. Here's what's important to know. The conditional and the contrapositive. Conditional and contrapositive are logically equivalent. The converse and the inverse are logically equivalent. So those are some other nice facts to know when we're working with the section on equivalent statements. Conditional and contrapositive equivalent, converse and inverse are equivalent. Okay. All right, so let's work some problems in here. Now, sometimes the homework will say, use a truth table to determine if the two statements are logically equivalent, because there isn't a De Morgan's law or one of those other equivalencies that you can easily apply. So here we've got two conditional statements that look sort of similar, but not. Let's see if we can show they are or are not equivalent using truth tables. So I'm going to set up a truth table for each of them, and then we're going to compare what we get in column 3. If it's the same, they're equivalent. Okay, so here's my first one. If Q, then P. I set up my Q column, my P column. And what am I looking for here? If it's true to false, it's false. Everything else is true. Pretty simple. My second one was if P, then not Q. So again, I went ahead and set the initial columns up in the truth table for you. And what am I looking for? True to false, which is in the first case. That's going to be false. Everything else is true. And I compare this column to this column. Do I see the same truth values in the same order? No. So these statements are not equivalent, because I didn't get the exact same truth values in the same order in that last column. They're not equivalent. Now the next problem says use De Morgan's laws to determine if they're equivalent or not. Did I put them here? I didn't put them here for you. Let me get the sheet up real quick. So here's the two De Morgan's laws. And let's take a look at what we have. We're starting on down here with the negation of a conjunction. So let's look at the De Morgan's laws. And we're actually going to want to use this first law, the negation of a conjunction. So let me jot that down here. So we want to use this law. Now, the problem I have doesn't look exactly like this, but it kind of looks like it. And so what we can do is we can map it on. So let's write down what we have. We have not P and not Q, negation not P and. Now look at the pattern on the De Morgan's law. Okay, when we go to the other side, what happens? The negation goes away. It's basically, if you want to think about it, it's being distributed really. P here becomes not P, Q becomes not Q. The conjunction becomes a disjunction. So what's going to happen down here? So if I had a not P here, what's it going to become on this side? It's going to become P. Conjunction becomes disjunction. Q becomes not Q. Is that what I had in the problem? Is that what they gave me? It is. So we can write those two compound statements are logically equivalent because I used a De Morgan's law to actually show that right here. I didn't have to do a truth table, and this is a whole lot faster than doing the truth tables because I would have had to do a truth table for this one and for this one. And you could do that, but it takes more time. But you see how I replaced the P here with a not P, but I followed the same pattern because when we use this De Morgan's law, P becomes not P. So if I start with a not P, it must become P. We had a Q, we kept the Q. The conjunction became a disjunction. I did the same thing here, Q went to not Q. And so I've proven that those two statements are logically equivalent. Okay, let's try another one. All right, so this one says, use De Morgan's laws to write an equivalent statement for this sentence. Franklin is wealthy and he is not famous. All right, so let's pick a P and a Q first. So P, Franklin is wealthy. And my Q, remember they're always not negated. Franklin is famous. Okay, so let's write this symbolically first. So remember, but is the same as and. So this is P and not Q. Now, take a look. And we want to write an equivalent statement. Let's take a look at our De Morgan's laws. Our connective here is a conjunction. Now we're actually looking at, coming into focus a little better. Shoot, doesn't want to focus. Come on. For some reason doesn't like that green so much. We're actually looking at the second one down here. So we're really kind of looking at it going backwards this way because we've got a conjunction and we want it to go the other way. So let me jot down that De Morgan's law on the paper for you. So here's the De Morgan's law that we're thinking about. Not P is logically equivalent to that. All right, so let's take a look at, we have P and not Q. This was not P, so not P, so we went to, the negation's going to go on the outside. So the P here went to, it was a negation P. We have a P here, so we must have a negation P over here. And we're going to go to, disjunction. And we have a not Q, so it's going to go to Q. So the only difference is going to be from the original De Morgan's law is we didn't have a not P here, so we end up with a not P at the end. So what are the words going to be? It is false that Franklin is not wealthy or he is famous. So that would be an equivalent statement to the one that we started with, which said Franklin is wealthy, but he is not famous. Sounds kind of clunky, but that's an equivalent statement for it. So it is false that Franklin is not wealthy or he is famous. Okay, now this one, I gave you a hint in the beginning because it's a conditional. I said use the fact that the conditional is logically equivalent to this disjunction. So let's pick our P and Q. P is going to be, Weezer is on the radio. I don't know who Weezer is, but, and Q is going to be, Ollie is working. Okay, so we want to write this symbolically first. So we've got not P, if not P, then Q. Now again, look at the equivalency I gave you up here. It starts with a P, but we have a not P. So P up here went to not P. So if we start with a P, we must go to, if we start with a not P, we must go to P. The conditional goes to a disjunction, and the Q stays the same. So what's my equivalent statement? Weezer is on the radio or Ollie is working, which is what's coming over here. So the original statement was if Weezer is not on the radio, then Ollie is working. An equivalent statement is Weezer is on the radio or Ollie is working. Okay, let's try another one. This is practicing the variations of the conditional. So here's the conditional statement. If I write a haiku, then you will write a sonnet. Let's write the converse. So here's my, let's just put the P and the Q below. So P is going to be, I write a haiku, and Q is going to be, you will write a sonnet. So what happens in the converse? Remember the converse? When we do the converse, what do? We flip the order. So what's that going to be? We're going to flip them. We're going to say, if I write a sonnet, then, I'm sorry, if you write a sonnet, if you write a sonnet, then I write a haiku. So this is, so now it's Q arrow P. This was P arrow Q, this is Q arrow P. The inverse is, if not P, then not Q. So what's that going to be in words? I'm just going to say it so I don't have to write it. If I don't write a haiku, then you do not write a sonnet. And the contrapositive is negated and flipped. If you do not write a sonnet, then I do not write a haiku. And I'll let you write those words out. But those are the variations of the conditional. So this was if P then Q, if Q then P, if not P then not Q, if not Q then not P. Converse, inverse, contrapositive. Okay, now on the next one, sometimes the contrapositive makes more sense than the original statement, and it's easier to determine the truth value by writing the contrapositive. Here's the statement. If the number is not a natural number, then the number is not a positive number. That might be hard to understand, and it might be easier if we wrote the contrapositive. So if this statement is not Q and this statement is not P, I would like to turn that around and write the original conditional statement. What would that be? So if this is not P, then P would be if the number is a positive number. Oops. Yeah, that's my not P. If the number is a positive number, then the number is a natural number. Now, the question is that a true statement or a false statement? If the number is a positive number, then the number is a natural number. Is that true or false? Anybody want to try?
False?
It is false. You're right. It is false. Because in order to be a natural number, it has to be what? It has to be an integer.
Correct.
Yeah, it would have to say if it's a positive integer, then the number is a natural number. But the way it's written now, this is actually a false statement. Yeah, that's actually false. That's a hard one. I think I have a couple more. I do. Yep. Oh, this is going to take a little bit more time, so we're going to need some alternative forms here. Determine which of the following, if any, of the three statements are equivalent. If Tim is the director, then Johnny is the actor. Tim is not the director or Johnny is the actor. It is false that Tim is the director and Johnny is the actor. Okay, so I already put the P's and Q's down for you. The first thing you want to do is write each statement symbolically. So I said let P be Tim is the director, Q is Johnny is the actor. So let's write each one symbolically. So the first one says if Tim is the director, then Johnny is the actor. So that's just going to be an if P, then Q. And then the second one says Tim is not the director, so that's not P, or Johnny is the actor. And then the third one, it is false that, so we know we're going to have a negation out front. Tim is the director, and Johnny is not the actor. Okay, so now we need to think about those equivalency statements that I showed you. Let me get that page back up again. So we had a couple things here. Let's take a look. So we've got a conditional and we've got a disjunction. We had an equivalency for that, didn't we? Remember? We had one right here. Remember this one? Okay, so let's take a look at that and see if that'll work here. So we can rewrite this one. If you remember that rule, P goes to not P. The conditional becomes a disjunction. Q stays the same. Guess what? That's the same. So A and B are definitely equivalent. Now I need to do something with C to figure out if it's equivalent to A or B. So C and B might be related how? Maybe they're related by a De Morgan's law. So I know a De Morgan's law that says this. Okay. So let's see if I can use that on the statement I have, which is similar, but not quite the same because I don't have a Q, I have a not Q. So what happens up here? The P goes to not P. The disjunction, I'm sorry, the conjunction becomes a disjunction. The Q went to not Q, so the not Q must go to Q. Well, does that look like the second one? Look up here. That's the same as B, isn't it? These are all equivalent. You don't have to go through. Once you've shown that B and C are equivalent, by implication, A and C would also be equivalent. And you actually have, you do have a rule that you could use. You could use, let's see. Well, no, you don't have a direct one. I don't think we have a direct equivalency that you could use. No, you don't. But you've shown it anyway. Once you show B and C are equivalent, since A is equivalent to B, then A must be equivalent to C. So these are all equivalent. And you do have some in your homework like that, where they're going to say, here are 3 statements, tell me, and sometimes none of them are equivalent, sometimes only 2 of them are equivalent. But that's how you do it. All right. So let me stop sharing for a minute. Ask if there's any questions, and we'll go over and look at some homework. All right, anybody have questions before I go back over to my math lab and we can look at some problems there? Go to my regular share. There we go. Okay, and that was 3.3. I've pretty much given you samples of all the problems that you're going to see. Let's just flip through real quick. Let's see. So this is one where you do, now this is a little bit different. This one here, it says write the statement in symbolic form and then you want to construct the truth table. So first, let me look at the drop downs here. Okay, so they kind of have you think about this in pieces. So it says, if you don't attend the meeting, then you'll arrive at the office on time, comma, or you'll take the day off. So right away, we know this is in parentheses. If you won't attend the meeting, so that's going to be not P, then you'll arrive at the office on time, which is Q. That's going to be the first one here. So this is going to be second one, yep. Then they're going to have you add on the second part. So this is going to become parentheses here, or, which is a disjunction, you'll take the day off, which is R. So you have the first part, which is in, so actually once you get the first part right, you can't miss the second part. Oh, but you haven't checked it yet, that's right. You haven't checked it yet. Or you'll take the day off, wait a second. Oh, it must be, no, wait. Oh, this one here. There we go. Now you're going to check it. I see. Okay. You have to check it row by row. Then they're going to have you go down row by row. So P is true, so not P is false. Now you're doing a conditional, false. Now remember, for a conditional, if the antecedent is false, it's always going to be true. Oh, what happened? Shoot. Wait a second. Pushed on something there. This is going to be true. Now this part's true, so you have true or true, so this is true. So this is building the table row by row again. This is actually not a bad one, actually. Okay, so this is going to be false again, because all first 4 cases here are all true. Now you've got, this is going to be true. So now you've got a true or, this has got to be true. It's pretty easy. Okay, this is true again. This is true again. No, wait, true to true. No, true to false. This is false. This is true to false. This one's false. So now I've got a false or a true. So this is true. Oh no, what did I do? True. True to Q is false. Oh, this is false. This is false. This is the false one. No, wait. This is false. This is where I made the mistake. This is false. These are both false. This should be correct. No, I still made a mistake. This is false. This is true. True. That's true. Okay. I put them in the wrong place. There we go. This is false. Now we have false to, oh, this is true. And true, this is also true, right? Those are all true. Okay, so we got the first part of the table done. Now we're going down to the part where P's are false, so the negations are going to be true. So we have a true to a true, so this is true. Now I've got a true or a true, so this is true. This is true. True to a true is true. And this is true. And this one's true. Now this is a true to a false, so this is false. False and a true is a true. And one more. This is a true. True to a false is a false. False or false is false. Well, I thought it was going to be a tautology, but there's only one false there at the very end. Okay, so that one goes row by row. This is similar to the one we just did. You're going to pick the correct answer with the correct truth table and compound statement. Let's see if there's any other different ones. Okay, one like this, in order to actually answer correctly, you're going to have to build a truth table. There's not going to be any other way for you to do that. So you would have to build a truth table and then determine if it is a tautology, a self-contradiction, or neither. So that would entail you building a truth table for that one. Same thing for that one. Same thing for that one. Okay, so this is putting in the truth values and determining it. So this is similar to the ones that we did before. You know how to do those. Yes. Same thing here. You know how to do those. Same thing on these. So these are similar to what you've seen before. This is what I just showed you how to do these, where you have some mathematical statements. Those are pretty straightforward. Same thing on that one. Same thing on this one, same kind of thing. And then you've got, I think, one graph at the end on this one. Yeah. Okay. And then let me look at 3.4 to see, because I think I've given you all the kinds that I could show you on the homework, other than the ones where you have to go row by row, and you're really going to have to do those in my math lab. Oh, that's 3.3. No, 3.4. 3.4. There we go. Let's see. Okay, these are definitions at the beginning. Okay, so here's one like we did in class. We may have actually even done this one. Use a truth table to determine if they're equivalent. So they're going to have you build the first truth table, then the second one, and then they're going to say, are they equivalent or not? That's why it's worth 3 points. Same thing on this one. Okay, on this one, they're having you put in the answers row by row. So you're basically building the two truth tables at the same time. Let's see if we can do this one together. This is a little bit harder. So let's do this one first. If not Q, then, if not P, then Q. So P is true, not P is going to be false. So this is going to be true. And true to a false, that's going to be false. So this is going to be false. And then over here, I've got Q, which is true. Oh, if and only if. True to a false is going to be a false. Let's see if we got that one. Oh, you have to do the whole table first. Oh, that's horrible. Sorry. I didn't realize you had to do the whole table first. Okay, let's keep going. So not P is false. That's going to be true. No, wait, that's false. I'm sorry. This is true. And then this is going to be false to false. So that's going to be true. Q is false. False to false is true. Let's see. This is true to true, which is true. And true to true, which is true. This is true. And this one is Q, which is true to true, which is true. And let's see, false. No, true to false is false. And well, once we've got one false, it's got to be false. Actually, I can just fill that in without doing the second part. Q is false. This is false. Let's cross our fingers and hope. Ah, we got it. Wow. Sorry, I didn't know how to do the whole thing at one time. Are they equivalent? Okay, let's take a look. False, false, true, 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 false, false. Are they equivalent? Yes. Yep. Oops. Go away. There we go. Okay, so that wasn't too bad. Now here you can use De Morgan's laws. So those are pretty easy. When you can use De Morgan's laws, you can just work that out on a piece of paper. On this one, you only have to worry about the antecedent here. Okay, because the conditional part's the same. So you only have to worry about using De Morgan's law on the antecedent portion here. So that should be pretty easy. Here you're going to use De Morgan's law to write an equivalent statement. So that was like the one we did with Franklin being wealthy. Okay, you should be able to do that one. Same thing on that one. Same thing on that one. This one, they give you a clue. You're rewriting it and they're giving you a clue up here on what to use for the equivalency. And same thing there. Same thing there. Same thing. Given the conditional, if P then Q, how does one write the inverse? That's pretty easy. And then we're going to write one of the statements here. So they give you an original statement and then they say write the converse or identify the converse. These are pretty easy. And then this is one of the ones where they want you to write the contrapositive and then use that to determine whether it's true or false. So I think you should be fine with these. And this is one of the ones where you have three statements. You have to rewrite them and figure out which ones are equivalent. And then I think, is there a graph one in here? Oh, no graph one on this one. Okay, that was on the last section. Okay, so we went over everything you're going to see in your homework, so you should be good. All right, question. So you have three things due tonight, 1.1, 3.1, and 3.2. And then we finished up the unit on logic today with 3.3 and 3.4. All right, any questions? We have a couple minutes left, so if you have any questions, now's your chance.
3.3 and 3.4 not due till next.
No, they're due next week. Yeah.
Okay.
Yeah. What's due tonight is 1.1, 3.1, and 3.2.
Okay. Okay.
Yeah. Next week, your unit test will be due too, though, because you'll be finishing up the unit next week.
Question.
Yes.
Can we use notes on those tests?
Yes.
Okay, so that's fine.
Mm-hmm. Yeah. When we come to the proctored exams, you're not going to be able to, but on the stuff you do at home, you can. Yes. Absolutely.
My other question for you about the proctored exams, are we able to have scrap paper with us?
Yes.
Okay.
Yep.
Cool.
Yeah,
cool.
And I think I'm going to put out the practice test because we're going to use HonorLock. I think I'm going to release that this week. So if you haven't used HonorLock, you'll be able to try it out. It doesn't count, but just so you can see what happens when you take a test with HonorLock.
Okay.
And then also I will give you a practice or a prep quiz for the midterm that you can take at home on your own over and over to help you get ready.
Okay.
Okay.
I was just wondering because I know with the truth tables, I'm going to want to write.
Oh yeah, no, you can have, yeah, you can have scrap paper. Yeah, yes, definitely. And remember, the midterm is going to be on 3 units, so it's not going to be a whole lot of truth tables, okay? Because remember, we did sets, then we did logic, and then we're going to do geometry. So
Gotcha.
you're not going to be doing a gigantic truth table like on every question. I don't want you to think that.
Okay.
You would never get finished. No,
that's what concerned me. I'm like, ah.
No, that wouldn't be fair. No. Nope, you'll be fine. All right, let me stop sharing.
So when we're determining on a truth table, like what is true and false, does that really just fall back to like the definitions that we're looking at?
The rules for what kind of compound statement it is. Is it a conditional? Is it a biconditional? Conjunction, disjunction?
Okay, and that determines whether or how we figure out what is true and false. Okay,
right.
I just wanted to make sure.
Yeah, whatever connective is being used. That's why when I labeled the columns, if you remember, let me just pull up real quick. Let me pull it up this way so I don't have to get back to that darn document camera, which keeps going out of focus. Let me go back this way. Pull it up this way. So we were doing. Let's do 3.3. All right, so let me get back over here and share the screen real quick. Okay. So for instance, this is some of the problems we just did. So for instance, on this one that we were just doing, you put your P's in here, which would be true, true, false, false. You put your Q's in here. Let me get my marker, my pen up real quick, just so I can do this real quick and show you. Let's do purple. Okay, so we would have true, true, false, false. This is false, true, false, true. Okay, so the decision I'm making this time is a conditional, and the rule for a conditional is it's only false when the antecedent, the P, is true and the consequent is false. So the first case is going to be, whoops, false. Everything else is going to be true. So that's how I make my decisions. It's going to depend on what the connective is above that column. So if you go down and look at, yeah, in this one, for instance, the first decision you made was this column here, which was the disjunction and or. So you were comparing column 1 and 2 with this connective. You get those answers, then we were done with this column and this column. Then you were comparing 4 and 3 and 4 with the biconditional, following the rules for biconditional, which is true when you have the same truth value for the two sides.
Okay.
Does that make sense? Yeah. So you're gonna have, those you're going to have to remember the rules for, because that's the only way you're going to be able to fill those out consistently and get them correct.
Okay. Thank you.
You're welcome. All right. Anybody else? Any questions? Abigail's good. Anybody else? Whoops. Put that down. Close it. Oh, wait, I have a chat. Hold on a second. Somebody's in the chat. Oh, that's fine. Okay. Somebody had to leave early. Okay. If there's no questions, you're free to go. And we'll meet again next week, same time. Have a good week.
Have a great week.
Okay.
Thank
Bye. Bye. Lucas and Laura, are you okay? Laura, you okay?